Oh, y'all, so like I said, we're going to start out with 6.1 support tonight, and then we'll do the college algebra. So 6.1 support deals with finding the domain of radical functions. And remember, radicals, and we're looking at just mainly square roots in this section. All right, y'all. So the main thing when we're dealing with the square root, when we're looking at a domain, you got to recall that the square root of a negative number is not real. So that means we cannot take the square root of a negative number. So we got to take that into account when we're looking at the domains, okay? So the smallest number we can take the square root of is 0. Okay, so 0 I can take the square root of, which will give me 0. But remember, if you try to take square roots of those negative numbers, you're going to get imaginary answers, which are not real. So we cannot exclude any numbers in the domain that give me a negative number under that radical, okay? So the steps to finding the domain on a radical. So remember, it can equal 0, but it cannot be a negative number. So what we're going to do, we're going to set the radicand, which is the part under the radical, and it can equal 0, so we're going to set it greater than or equal to 0. Now remember, the radicand, like I said, is what's under the radical. So I set that greater than or equal to 0. I then solve for the variable. And then write the domain. And in here, they're not using interval notation. They're just using set builder notation. So that'll be like X such that X is greater than whatever numbers I get on this, okay? And that's the main thing. What's under the radical, set it greater than or equal to 0, solve for the variable, and then write our domain. So y'all, support has 3 problems doing this, and then we'll get into the college algebra where they have 1. So for this first one, they want me to find the domain of f of x equals the square root of 100 minus x. All right, so my radicand for this one will be the 100 minus x. So I would take that and set 100 minus x greater than or equal to 0. Now you got to solve it for the x. So the first thing, we need to move the 100 over by subtracting it from both sides. So those 100s cancel out on the left side. I'm left with that negative x. greater than or equal to a negative 100. So now you got to be very careful because remember, I'm dealing with an inequality. And to make that a positive x, I'm going to divide both sides by -1. And y'all remember, since I'm dividing by negative, I've got to reverse the inequality. So instead of greater than, this will now be less than or equal. So reverse the inequality since dividing by negative. All righty. So that's going to make this negative x divided by -1. That's going to make that a positive x less than or equal to, and then -100 divided by -1 makes that a positive 100. So this is telling me any number less than or equal to 100 will give me a 0 or a positive number under here. Any number greater than 100 will make that negative. So y'all, 100 minus 100 is 0, and the square root of 0 is 0. But if you put a number bigger than 100, such as 101, 100 minus 101 would give you a -1 under the radical, which would make it not real. So that's why for this problem, our x's has to be less than or equal to 100. So for set builder notation, we would have x such that x is less than or equal to what I got, which is 100. Now I'm going to write this in interval notation because I think in the support part of this, they're going to write it in interval notation method. So it includes the 100. So in interval notation, and remember, 100 is the biggest number it can be. So since it's got to be less than 100, it's going to start at -infinity and go all the way up to that 100. But y'all, this is like the domain problems we did last week with the range, when we did the range. Since it can equal 100, you got to use the square bracket. So use the square bracket around the 100 since it is included. Okay, so college algebra is going to do set builder notation. The support will use the interval notation. Okay. And just remember, if it's less than, it's going to start at -infinity, go to 100. If it's greater than, it'll start at the number and go to positive infinity. So y'all, let's do another one of these. So same thing, find the domain of f of x equals a square root x minus 10. And y'all, tell you, x minus 10 is under the radical. So I'm going to set that. X minus 10 has to be greater than or equal to 0. And then we'll solve this one. Looks like we just got to add 10 to both sides. You know, this tells me my x comes down, 10's canceled on the left side. It's greater than or equal, and then 0 plus 10 gives me 10. So I didn't have to switch to inequality because my x was positive and I didn't have to divide it like I did up here. So the final answer will be x greater than or equal to 10. So for college algebra, we would have x such that x is greater than or equal to 10. Now for interval notation, 10's the smallest number it can be. So this time 10 will be the starting number with the bracket because it can equal 10, remember. And then greater than heads off towards positive infinity. So I'll tell you a trick. The little inequality when your final answer will show you the way to put the infinity. If it's pointing left, I'm going to negative infinity. If it points right, then I'm headed towards positive infinity, okay? And y'all, let me do one more support, and then we'll look at the 6.1 college algebra. And like I said, support only had the 3 questions. And this one will be find the domain. Of f of x equals 12 minus x. And this is sort of a trick question for you. Because my function is 12 minus x. I do not have a radical on this. So remember, on domains, I'm now worried about radicals. And then the only other thing I'm worried about on a domain is a fraction. And y'all, you do not see a fraction here. So there's no fractions. No radicals. So since I don't have a fraction to worry about, I don't have a radical to worry about, this domain is all real numbers. So for college algebra, you would have the what? X such that x is a real number. All real numbers for support, if I was going to write them in interval notation, all real numbers would be negative infinity to positive infinity. Okay. So y'all, that's the support. And like I said, it was just to get you ready for 6.1 college algebra. So y'all, let's get started into college algebra. And this 6.1 is radical functions. Now, all we're going to be doing in this section is finding one domain problem, and then the rest of them are choosing which graph is correct. So this one will say determine the domain of the function. They're giving us f of x equals square root 2x plus 1. All right, so I got my function. I got a radical. And since I got a radical, I know that the 2x plus 1 has to be greater than or equal to 0. So let me set that 2x plus 1 greater than or equal to 0. We'll now solve that for the x. And once we got that answer, I'll write my answer in set builder notation for college algebra. And y'all, looks like we got a couple things to here. We're going to move to 1 first by subtracting. So bring down your 2x. Those ones cancel. And it's going to be greater than or equal to -1. Now notice, I do not flip that when I subtract. It's only when I divide by negatives, okay? And this x is positive, so I'm going to be dividing by positive 2. So I do not reverse that. And y'all look here, the 2's cancel, giving me 1x greater than or equal. And y'all, we cannot do nothing to that, so that's going to stay a negative 1/2. So for my answer in Math Lab, I would have x such that x is greater than or equal to a negative 1/2. So set builder notation is basically a x, a bar, and your answer. Okay? All right, now then they start having you graph. So this one says graph the function f of x equals 3 times square root of x. Now I'll graph this on the paper. Now I'm going to show you on the calculator. But if you was doing this by hand, you would set up an x and y table. Now I'm going to be very picky on these x's. On these x's, I would not pick an x that was not a perfect square. And remember, perfect squares are 0, 1, 4, 9, 16, 25, 36, and so on. 0 times 0, 1 times 1, 2 times 2, 3 times 3, and so forth. You want to have numbers inside that radical that have square roots, or you're going to be plotting some decimal looking answers, okay? So for this one, I'm going to pick the 3 smallest numbers here, 0, 1, and 4. Just to get an idea of what the graph will look like, okay? So if I put a 0 in there, square root of 0 is 0. 0 times 3 is 0. So my first point will be 0, 0. Then I'm going to put a 1 in for the x. So if I put a 1 in, square root of 1 is 1. And then 1 times 3 gives me a 3. So my second point will be 1, 3. And then y'all, I'm going to put a 4 in there. Square root of 4 is 2. And 2 times 3 gives me a 6. Now, y'all, I didn't use a 2 here because the square root of 2 is like a 1.41 never-ending decimal. And the same thing with the square root of 3, it's a never-ending decimal. So if you're going to do this by hand, those x's got to be these kind of numbers. Okay? All righty, so I got 3 points. So y'all, here's my x and my y. So my first point, 0, 0, well, that's going to be right here in the origin. Now, since this one only had the x under the radical, you cannot put any negative x's because those are going to make it not real or undefined. All right, my next point was 1, 3. So right 1, up 3. And remember, these square root graphs go to the right, but that 3 that's in the front is making everything sort of like 3 times bigger. And then here I had 4, 6. So right 4 and up 6. So y'all, at that point, you can see that that graph is sort of going to curve uphill to the right. And like I said, they're going to have 4 pictures to pick out on that one. So these would be your 4 pictures. And notice mine would be B because that's the one that's sort of going uphill and to the right. Okay. So that's going to be the trick on the graphing, is just to go through there and pick X values that are perfect squares. Okay. All right, y'all. So I'm just going to let me show you that one on the calculator. So remember, I had f of x. So this one was f of x equal 3 times the square root of x. So on the calculator, let's see if we can get that graph. So I'm going to share my screen to the calculator. Whoops, I don't have it up yet. Let me pull it up real quick. All right, y'all. So now I'll share it with the calculator. All right, so to do that, I would go to my y equals. So let me clear that one out. So I had 3 square root of x. So I would hit my 3. My square root will be second x squared on the left side, right above the 7. And then put my x in there. Whoops. So delete one of my x's off. All right. So I'm going to show you the graph real quick by hitting graph. And there it is. It's sort of going uphill to the right. And let me fix I'm going to go back to zoom 6. And that'll put me on a 10 by 10 graph. There you go. Now remember, let me show you what happens when you hit second graph and look at the table. Any of these negative numbers, I'm getting an error message. That's because they're not real answers when you put negative numbers under that radical. And then look, square root of 1 gave me the 3 like I had. 2 would give you a decimal. 3 would give you a decimal because they're not perfect squares. But 4 is a perfect square. And I got 6 as my y value. Then the next perfect square was 9. So look at all the decimals until I get to 9. And I get an actual number I can plot, okay? So, and again, it shows you that the smallest x value you can pick was 0, in fact, okay?
I have a question.
I hear you.
Okay, so I think it was last Wednesday we discovered that when I do square root, it like wants me to put it in parentheses or whatever.
Mm-hmm.
Remember that? Okay, so I'm doing y equals 3 square root of x, and I close the parentheses, but when I press graph, it says error.
Okay, so do this for me.
Okay.
When you press error, it should have 2 options. It should say go to. Is it
Hold
saying
on.
go? Does it say go to when you get the error message?
No, it says error window range number 1 quit.
Okay, so let me think here a second. So window range means, so let me share my calculator. So I'm gonna go to my y equals.
Okay.
Are you showing plot 1, plot 2, or plot 3 highlighted on your calculator?
Plot 1, 2, and 3.
Are any of them dark? Let me show
Uh,
you what so look at my calculator right now. I'm going to show you what I'm talking about. So are
yes, sir.
any of yours now watch when I go to y equals. See how my plot 1's dark now?
Yes, sir.
Are any of yours doing that?
No, sir.
Okay, so that ain't the problem. So let me fix the mine back. All right, so now I want you to do this. Hit zoom, the zoom button in the middle,
Yes, sir.
and go down to number 6 and hit standard and enter.
Okay.
Is it graphing now?
Yes, sir, it is.
Okay, so something must have been up on your numbers must have been off on your Windows settings.
Okay.
Okay.
What should they be on?
Well, now everything should be at -10, 10, -10, and 10.
Okay, okay.
So you
Thank
won't have
you.
you won't have to change them unless you physically change those, okay?
Okay, yes, sir.
Okay. All right, Lily, you're good. All righty, y'all. So most of them are doing that. Let me find one here where they do something a little different. How about f of x equals square root x plus 5. Now, y'all, I'm going to tell y'all the truth on some of these. They're giving you 4 pictures. If you remember what the basic graphs look like, so let me show you the basic graph on these. The basic graph would be 0, 0, 1, 1, 2, 3, 4, 2, 9, 3. So these basic graphs sort of go uphill to the right when the function is just a square root of x. But y'all, on this problem, look what happened here. I got a square root of x plus 5. You could almost figure out which picture this is if you remember the translations. Now, I'll probably do this one by hand also to show you what I would do. But on this one, if you add 5 to the x, and remember, if you're under a radical, it's like you're in parentheses. So that's either going to move me left or right. And remember, since that's being added, it's going to take this graph and technically move it left 5 units. Okay, so remember, you can almost do the translations on this. So left 5 units would be 1, 2, 3, 4, 5. And then it's going to start doing its little thing, 5 units left. All right, but let's graph it by hand and I'll sort of show you. Now remember, I want this to equal perfect squares under the radical. So the smallest perfect square I had was 0. So to make that equal 0, that x is going to have to be a -5. Because -5 plus 5 is 0. Square root of 0 is 0. Now, I'm going to try to make this equal 1 under here. So to make that equal 1, the x has to be a -4. Because -4 plus 5 is 1. Square root of 1 is 1. Now, what's next? I did 1 and I did 0. So next smallest number would be 4. So to make this equal a positive 4 under here, that x has to equal -1. So y'all, -1 plus 5 is 4. Square root of 4 is 2. So you got to focus on making this equal a number that has a square root, okay? Now the calculator, like I said, you can go right to the table. So let me clear that out. And I had a square root, so second square root. And then I had an x plus 5. All righty, so let's look at the graph. Now remember that graph, we said it should shift it left 5 units. And y'all look at that, where it was at 0, 0 is now at -5, 0. It pulled the whole graph over 5 units. And then look at your table, second graph. So let me go up until I start getting them error messages. So the smallest number I said we could use was -5 because that gave me the 0. And look at that, -6. If you put that in, -6 plus 5 would be -1, and you're going to get the error message, okay? So the trick is, y'all, is to just make sure that the radical part stays above or equal to 0, okay? And y'all, really, they're giving you 4 pictures on those. So the one I just did, notice this one went up. This one actually went left like I needed. This one looks like it flipped around somehow. And then the last one went to the right. So you would pick the one that went left, which would be the B, okay? And y'all, that's mainly the 6.1. So I'm going to do a little bit of 6.8, probably not much, so you're not overwhelmed. I wanted to get through about the first 5 or 6 problems on this. So I'm going to get us into 6.8. And this deals with increasing, decreasing, which we've already done. But the new thing in this section is the piecewise functions. And y'all, this actually starts off with piecewise functions, okay? So let me give you a little definition. So, and I'll show you an example of an everyday type situation where you would use piecewise functions. But the actual definition of a piecewise functions, it's going to be a set of equations in which the domain determines which equation is used to find the function value. Okay, so it's a set of equations, 2 or 3, and the domain, they'll give you a domain at the end, and it's going to determine which equation I use to find the function value where I plug in my number and get my answer, okay? Now let me show you an example of a piecewise function. So this one will be P of A, I'm going to call mine P of T. Now I'm only going to use 2 equations on mine. So my P of T will equal 20 times T. So I'm going to use this equation for any T that's less than or equal to 40. Now my second equation is going to be 800 plus 30 times T minus 40. I will use this equation for any T that's greater than 40. So y'all, let me explain what I got here. I got a set of equations that someone would use if they made $20 an hour. So if you work up to 40 hours, Your pay is determined by $20 times the number of hours you work. And we would use that all the way up to 40. Now, overtime happens when you work over 40 hours. So if you're working over 40 hours, 800 is your pay for 40 of those hours. So 40 times 20 gave me the 800. And then to figure out the overtime, 30 is time and a half for $20. And then you would take your total time minus 40 to see how many hours of overtime you had. So say you work 45 hours, you would make the 800, and then 45 minus 40 would give you 5 hours at time and a half. Okay? So if someone worked, so if I was going to find P of, say, 20, if someone works 20 hours, I look at the domain to figure out which equation I use. Well, y'all, 20 is less than 40. So I would use this equation, and I would do 20 times the 20 hours, and that'd give me what, 400 or so. So if I want to find P of 20, I would use the 20T equation, okay? So they're going to give you sets of equations, and they're just going to know which equation you're going to use to find the value they want you to find, okay? And y'all, what if this one I had find P of 50? So if someone worked 50 hours, well, 50 is greater than 40, so I would use this equation, which would be 800 plus 30 times my T minus 40. Okay? So if y'all worked a job by the hour, I'm sure if you worked up to 40 hours, you multiplied your pay times your time. And then if you worked over 40 hours, y'all figured out what time and a half was and multiplied that times the hours of overtime you made, okay? Same thing on these, okay? All right, y'all. So for college algebra, they say the piecewise function f is defined as shown to the right. Then they say identify the expression that should be used to find f of a -9. All right, so the function they're giving us is f of x equals, and y'all just has 3 equations. It equals x minus 2 for any x less than -5. It equals x squared for -5 less than or equal to x less than 4. And then it equals 8 times x for any x greater than or equal to 2. So they want me to identify the expression that should be used to find f of -9. So what we got to do, we got to figure out, is -9 less than -5? Is -9 equal to -5 and less than 4? Or is that -9 greater or equal to 2? Well, y'all, -9 is definitely less than -5. So since -9 is less than -5, for this situation, to find f of -9, I would use the equation x minus 2. Now, at this point, they don't want me to figure out what the answer is. They just want to know which equation I would use. All right, so I'm going to try another one, y'all. All right, so on this one, we're just going to identify the expression that should be used to find. So on this one, they want me to find f of 10. All right, y'all, and this one is f of x equals 3x 4x less than -5. It equals x squared 4 -5 less than or equal to x less than 2. And then it equals x minus 4 for any x greater than or equal to my 2. All righty, so we got to find where 10 is. Is 10 less than -5? Is 10 in between -5 but less than 2? Or is 10 greater than or equal to 2? Well, y'all, since 10 is greater than or equal to 2, we would use the equation x minus 4. All right, y'all, so I'm going to pull one thing up for this thing. I'll let y'all catch up while I'm pulling something up. All righty, almost there. I need to go to numbers. All right, y'all. So I'm going to share my screen for the next few problems. Is doing the increasing and decreasing. So I'm going to do these on MathLab using their graphs. Okay, so let me share the MathLab. And then I'm going to make this graph bigger. And y'all, we just did these last week. So A, B, C, or D, where is this increasing? And remember, when you're looking at increasing and decreasing in constant intervals, we only care about the x values. So I'm going to pull my cursor over here to where that starts going uphill on the right side. And if I go straight up, it looks like I'm hitting 2 on the x-axis. So it's going to start going uphill at 2. And then it's going uphill as my x's go to the right. So this one's headed towards positive infinity. Now remember, on intervals, They gotta be in parentheses. So y'all, this one, y'all definitely gotta pick A on this one, right? They start going uphill at 2, and it's going uphill as I head towards infinity. So you pick A on that and check your answer. So constant, where does it start being constant? And then where does it end being constant on those X values? And y'all, constant is right down here where it's flat, going straight across.
-2, +2.
So -2, +2. So perfect. I'll use what? An A on that one. All right, let's check and see. There you go. And then you know it's going to ask for the decreasing. So y'all remember, all those arrows pointing left, it's really coming in from the left. And it's decreasing as you go down those X's and get to that X where it starts going flat. So we say this one's coming in from negative infinity. And then we're just cruising down the X-axis until we hit, oh, I guess it's going to be that -2 you gave me that started the other one, right? So this would be from negative infinity to -2. So you'll notice those points, -2 and 2. -2 was the point on the X-axis where it went from decreasing to constant. And then +2 was the point where it went from constant to increasing. And y'all look at these. These are the same exact problems you did last week. And these were like support questions last week. You got 2 places where it's going uphill. So it's got to be A or B. And usually if you find just one of them, you'll have the right answer. So I'm looking at this second line, that the second line is going uphill left to right. I'm going to figure out where that first dot is. And that first dot on the second line going uphill, that dot looks like it's at -6 on my X-axis. And that line goes uphill as I go right on the X's. And then it stops at the Y-axis. What the Y-axis, the X value is 0. So I'm going from -6 to 0. Now D has -6 to 0, but I need that other piece over here. The fourth line is going uphill also. So I'm betting this is going to be A, but let's find where the V is. I'm going to go up and see what that X value is. So 1, 2, 3, 4. That looks like 5 on the X-axis. And as I go right on the X's, it's going uphill until I get to 9. So yeah, A would definitely be the only answer you can pick. You're going to check the answer. On what interval is it decreasing? Well, y'all, the third line is going downhill left to right. So the third line is the one I need to figure out what that starting X value is and the ending X value. So let's get that top point on the left of the V, see what that X value is. And y'all, that looks like what? 1, 2, 3. So I'm going to put in my 3. And the ending X value is going to be the beginning X value on the last part that went uphill. So the V dot, if you go straight up, looks like that's at 5 on the X-axis. So your whole trick on these is to stay on the X-axis, okay? And then constant was this little one going straight across the first little line here. So I need to figure out what X value it starts at and what X value it quit. So the black dot, if you go straight up, that looks like -8 on your X-axis. Then you got the hollow dot where it ends. If we go straight up, that looks like, let's see, 1, 2, -6. All right, y'all. So those are basically the same as you did last week on the support. So what I'll have y'all do for your homework, do 6-1 support, 6-1 college algebra. For 6-8, work up to number 7. And then when we come back Wednesday, I'll start at number 7 and finish the rest of 6-8, and then we'll knock out 5-4. And I think 5-4 had like 5 questions, so it's not real big. And remember, 5-4 is the last information for test 2. Okay. So 6-1 support, 6-1 college algebra, and up to number 7 in 6.8. And then like I said, I didn't want to finish all the 6-8 because it's got a few more things in it, and I didn't technically want to overwhelm you tonight, okay? All right, y'all. So I will take any questions.
I have a question real quick.
I hear you.
So when you did on what interval is the function decreasing, you put 3, 5. How did you find that again?
Okay, so let me go back to that. And that was the last one I did with the 4 lines.
Yes, sir.
Okay, so let's look at that real quick. So I'm going to make it do a similar question. So let me make this bigger, and we'll run through the first one here.
Okay.
So uphill, let's see, that first one looks like -1, 2, 3, -4. So -4 to +2. So the only one it can be on that one would be C, because it has
Okay.
2 going uphill, right?
Yes, sir.
All right, so the one you was wanting is this next one. So decreasing. So if you look at the lines, the third line is going downhill left to right.
Yes, sir.
And remember, you always got to go left to right on your lines, okay? So
Mhm.
if I was going in, the first one would be constant. The second line's uphill. This third line was my downhill decreasing. And then the fourth one was uphill. So let's look at the third line that's decreasing. I'm going to go to the dot that's on the top left of that line. And I'm going to go straight down to the x-axis and see what that value is. So if we come straight down to the x-axis, that looks like, what's that? 1, 2. Looks like I'm sitting at about 3 on the x's, right?
Yes, sir.
So we'll put our 3 in for that's the x value that it started at.
Okay.
Now, the line goes down until it gets to the V point right there.
Yes, sir.
So of that V point, that dot, we need to figure out what is its x value. So I'm going to go straight up to my x-axis. And let me count these lines over. Looks like we're at what? 1, 2, 3, 4, 5. Looks like 6 on the x-axis to me. Right, if I follow that line straight up, that would be where 6 is at on the x's.
Yes, sir.
So then you would just put in your 6 and be done with that one.
Okay.
And then how about the constant? So the constant is my little straight line there. So what I need is the X value of that dark point first. So I'm at my dark point, so I'm gonna go straight down to the X axis. And let's see. I got -10, -9, -8,
Is it negative
-7.
7, -4?
So -7. And then -4. That looks good to me. So you just punch that in there and check those answers.
Okay, that
Okay.
makes more sense.
Mhm.
Thank you
So you
so
just
much.
and you really just gotta focus on your X axis there, okay?
Yes,
Stay away
sir.
from them Y values.
Yes, sir. Thank you.
All righty, no problem. All right, anyone else? So y'all, hopefully this ain't too bad tonight. You got your domain stuff. And the domain of a radical has to be greater than or equal to 0. And then you're just picking out graphs. Just remember, if you graph those by hand, whatever's under that radical, you want that to be a perfect square, okay? So that you can get a number out of that. And then piecewise functions. Use the domain to pick which of those expressions you're going to use. And then y'all ended up doing the increasing, decreasing. All right, that'll work, Beth. That'll work. And you'll see this week is sort of mellow compared to some of the others. So yeah, if you're